Now let's look at some information from the graph of a function. Here, we want to be able to determine the domain and range of a function from its graph. If you remember, the domain of a function y equal to f of x is just the set of all input values or the set of all x values, and the range is the set of all output values or the set of all y values. So from the example here, we want to use the graph to determine the domain and range of the function. So we look at the input value for the domain. So it's the input value, the x values. So for our x values, we know our graph. So we want to look at the x values of our graph. So our graph starts at x equals -3. It would help if you actually draw a line perpendicular to the x-axis, and that's your beginning point or starting point. So it's from -3. Well, -3 is included because you see it's shaded here, so you include -3. So -3, 2, and then the graph goes up to 6. So it is from -3 to 6. So you look at the x value. So the x here is 6. So it's from -3 to 6. That is your domain. Now the range is the set of all output values, the y values. So for the y values, you look at the projection onto your y-axis. So in this case, it would be helpful to also draw a line that would intersect the y-axis. So, the y starts at here, at this point here, that is 0, and up to the highest point is this. Look at that. So your graph has a y value between 0 and this point here, which is y equals 6. Y equals 6. So therefore the range is just the value from 0, so including 0 because this is shaded, up to 6. So range is from 0 to 6. Now in the example here, we use the graph to determine the domain and range of the function. So again, when you say domain, that is the set of all input values or the x values. Then it could help if we draw a line. So this line through this point, that's the starting point. Okay, and then it would intersect the x-axis. So we know it starts at -5, and that is included because this is not open, that is shaded. So it is from -5 up to, then it goes, and there's an arrow here. That means it goes up to infinity. So the domain is -5 to +infinity. Now for your range, you look at the y values. So we know that the graph would actually not cross beyond y equals 3. Y equals 3. It will just approach this line here, but it will not touch. It will not touch. So that means y cannot be equal to 3. So that means it is from 3. So that is not included because it is asymptotic at y equals 3. Up to, so the highest point here is this point here, and the y value here is 8. So it is 3 up to 8, and 8 is included because it is shaded here. So the range is from 3 to 8, 3 not included. Next is to find or identify the intervals in which the function increases, decreases, or is constant. Now a function is increasing on an open, so take note, it should be open interval. So on an open interval I, if f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2. So for increasing values of x, your f of x is increasing. In other words, if you actually look at the graph, so if you look at the graph, for instance, a graph here, we know that the function is increasing if you connect 2 points, and then it will have a line that has a positive slope. So if it is rising, if the graph is rising, then the function is increasing. Now, a function is decreasing on an open interval whenever if you have increasing values of x and your y values is decreasing. So on your function or in your graph, you look at the interval for which the function is falling. And then for increasing, the function is rising. And then a function is constant on an open interval if f of x sub 1 is equal to f of x sub 2 whenever x sub 1 and x sub 2 are in the interval. Now, in other words, if you look at the graph, a function is constant on an open interval if the function has no change. Okay, so we'll have no change here. Now, if you look at this example here, for this first example, let's identify the intervals for which the function is increasing. So we know increasing, the graph is rising. So in this case here, we have this interval. So the graph is rising on the interval. So this interval here. Let's make a line that crosses this point here. Yeah, those are the points. We will identify what type of points is this. These are actually a minimum and a maximum point. So we know that from this point up to this point, that would be our marker. The graph is rising. So in other words, the graph is increasing in this interval. And of course, we would always write an open interval. So it is from -1 to 1. So the open interval -1 to 1, the function, -1 to 2. This is 2. And that's -1. So it's -1 to 2. So on the interval -1 to 2, the function is increasing. Now, if you look at these intervals here, the function is falling. So we have falling here, and the function also falls here. So on those intervals, the function is decreasing. So the intervals or the function is decreasing on, again, always write an open interval. From -5, so starting at -5 up to this point here, and that is -1. So starting at -5 to -1, and also it is decreasing starting at 2 up to this point here, and that is x equals 6. So it is from 2 to 6. Now, there's no interval for which the function is constant. So this is just a none. Now let's consider the function here. We want to identify the intervals for which the function is increasing, decreasing, and constant. So we are going to divide it at these markers here, because that is where the direction of the graph changes. So let's just divide them at the points where the graph changes its direction. Now, for increasing, that means rising. The intervals for which the graph is rising, and always write an open interval. So the graph is rising, and also you have to start from left to right. So from left to right, look for the part of the graph where the function is rising. So in this case here, it's rising. So on this interval here, now there is an arrow. That means it starts at negative infinity up to this point here. Up to what value of x? X equals negative 6. So in that case, f is equal to negative 6. So you have negative 6. So negative infinity to negative 6. Where else? So this one is falling. That has no change. This is rising. So also from negative 1, so you look at the x values. So union negative 1, so negative 1 up to this value of x here, which is 0. So negative 1 to 0. These are the intervals for which the graph is increasing. Now, the intervals for which the graph is decreasing. So again, it's always an open interval, decreasing. So the graph is falling. So whenever you see decreasing, the graph is falling. So the graph is falling on the interval negative 6. So starting at negative 6 to x equals negative 4. So this is negative 6 and this is negative 4. So from negative 6 to negative 4. Union. All right, so is there any other interval for which the graph is falling? There's none. So that's the only interval for which the graph is decreasing. Now, the intervals for which the graph is constant, that means no change. So it is on this interval here, and that is negative 4 to, so it starts at negative 4 and it ends at negative 1. Negative 1. Union, also in here, on this interval here, so starting at 0 to positive infinity. These are the intervals for which the graph is constant. Next, we want to be able to use the graphs to locate the relative maxima or minima. Now, a function value f of a is a minimum, this is a relative maximum, if there exists an open interval containing a such that f of a is greater than f of x for all x in the open interval. That means that this f of a here is a relative maximum if there is an interval for which f of a is the highest value. So f of a is the highest value. So highest value on an open interval. Now, it is a relative minimum if f of b is the lowest value on an open interval. So this is, it's called a minimum if it is the lowest value. The lowest value on an open interval. So, for instance, in the example here, we want to use the graph to determine the values of x for which the function has a relative maximum, and we want also to find the relative maximum value. So we just look for open interval for which we have a highest point. Maximum value is a highest point. So it is actually this point here. Now on that point, the x value here is the x value for which the function is a maximum. So this is a maximum. This point here is a maximum point. Maximum point. Now, the x for which the function has a relative maximum is x equals 11. And also, what is the maximum value? So the maximum value, the value is the y value. That's the y. So y is equal to 121. That's the maximum value. Now, minimum, it is a minimum if it is the lowest point. So there's an open interval for which it is the lowest point. This point here on the graph is a minimum. That is a minimum. So it has, so the x value for which the minimum point occurs is at x equals -11. So the x coordinate here is -11. And the relative minimum value, that is the y value. And that is just y equal to -1 to 1. Now consider the graph here, and we want to find the values of x for which the function obtain a relative maximum or relative minimum, and we want to find the relative maximum value or the relative minimum value. Now if you examine at the graph here, this graph here extends up to positive infinity and also extends to negative infinity. So because of that, we know that the function does not have a highest point. It does not have a highest point. And also there's no change in, there is a change in curvature, but it is actually decreasing. The graph is decreasing here. And then up to here, and then it continues to decrease. So the function is just decreasing all the time. So in this case, we have no maximum, no minimum. So this is none on both. Now for the function here, this function goes up to, it approaches the line here, the line y equals 2. So from here, it approaches the line here. It will not cross that line, but it will just approach 2. Now, because of that, because it will just keep on approaching it and we don't know where it stops, then we can say that we cannot tell what really the maximum value is. So in this case, there is no relative maximum because there's no open interval for which that value is the maximum. So in this case, there's none. There's no maximum point. But there is a minimum point. This is a minimum. So this point here is a minimum, and the value of x for which the minimum point occur is at -1. And the minimum value, the relative minimum value, is the y value, and that is equal to 0.